Today we worked on Chapter 6, Section 1. Chapter 6 deals with percent notation. And we started off with a couple of ideas about a little bit about the history of percents and the usage of percents. But this image is in the PowerPoint slides that are in MathExcel, and you'll notice that it's a very similar image to the one that we had when we studied decimal notation, where we had the entire object then divided into 10 slices and then 100 cubes and then much smaller to get it to 1,000 pieces. And so this is a good image because what it's saying is, look, it's saying that really that percent notation is just another way to express the idea of a number. So percent is just a number per 100. And so you can see there's an immediate connection between percent notation, decimal notation, and fraction notation. They're the same ideas. So here we go. 40% can be thought of as 40 out of 100 or 40 hundredths. And this image is 100 small blocks, and they have shaded in 40 of them. Now, another idea that we discussed, and let's chat there for a second before we look at these problems, is that if you go back and look in history at this whole idea of percents, you can really trace it back, perhaps further, but we can at least trace it back to the Roman Empire. And the idea was that in their culture, they had somewhat of a barter economy in places where people would exchange goods with each other. Also, you had the idea of perhaps not a standard currency. And so the Roman Empire was needed taxation, tax money from its far-flung empire. And an idea was to say, if you have olive trees or goats or grapevines, then what the Roman Empire said is, look, I want the product from per 100, meaning if you had a grove of olive trees, I want the olive oil from 100 trees. If you have goats, I want the goat cheese from 100 goats. And if you had grapevines, I want the wine from 100 grapevines. And so this became known as the per centum, meaning per hundred, per centum. And we even get our denomination name for our penny, the cent, as from this notation, because it takes 100 pennies to make a dollar. Now, also another usage that is very common is this idea of having a test and having the test count equal weights, but having different numbers of questions. So here's a situation where a student had a test with 20 questions and got 17 correct. Another test counts the same in the grade point, only 15 questions and 12 correct. Obviously, the student can go around saying, oh, I'm doing great in that class. I got 17 out of 20 and 12 out of 15. And that's about as far as the comparison can go. However, what we do is we turn that into a per 100 basis or per 100 notation. Pretty simple, and you'll see as we go through some of the problems that what we do is we'll just write this 17 correct out of 20 as a fraction. We will divide and turn that into a decimal. And so this decimal is 85 hundredths. By definition, that's 85 over 100. And also by definition, that's 85%. So the idea is if you have a decimal, if you will move the decimal point 2 places to the right, add the decimal to right, 2 places to the right, add a percent, you've got it. And so over here, different number of questions, same process. And so this score is an 80. So now the student can say, oh, I made an 85 and an 80%, regardless of the fact that there were 17 out of 20, 12 out of 15. And then maybe the next test would be 33 questions and 28 correct. And so we would have to do the same logic. We would have to convert this to a per 100 basis. So what percents allow us to do is it allows us to compare quantities where the total amount is not the same. So here's a 20 question, 15 question, maybe a 33 question test, and I want to compare them on the same common basis. And so what do? I put them on a per 100 basis, basically. Now, here were the 6.1 problems, and in the slides go to the conversation that there's really three ways that you can think of a percent. You can think of it as a number per 100, or you can think of it as a number times 1 over 100. And actually, if you do this multiplication, you're going to get this one. Or you can think of it as a number times 100, times 100. And so the answer to the first one here is B. That's the answer choice. It matches up to 90 per 100, 90 times 1 over 100, and 90 times 0.01. Now, we have percent notation, and we want to go to a decimal. What we have percent, and we will go to a decimal. How do you do that? You start with the decimal, you drop the percent, and you move the decimal to left. Say that again. You drop your percent sign and move the decimal to left. So, for example, this is 900%. So I view that initially just as 900. And can you see that? 900. And then I'm going to move the implied decimal point 2 places to the left, and I get that the decimal notation is 9. And that was answer choice A. They did not include the decimal point 00 here, but that's okay. We know that this and this are still 9. Drop percent, move decimal to left. Drop percent, move decimal to left. This one's a little harder because they gave it to us in fraction notation. So what do? We first convert this fraction to a decimal. How did we do that? Well, we simply said 2 divided by 5. 2 divided by 5 is 4/10. So I rewrote this as 2 and 4/10. Now I'm back to drop percent, move decimal, drop percent, move decimal, 2 places left. And on the next page, we had another one that was given to us. It was given to us as a fraction. So what did? We did the same thing. We said, let's turn this into 2500ths by dividing. Now we have this, drop percent, 2 left, and we get the decimal equivalent value is what? 5,925 tenths, hundredths, thousandths, 10,000. So it's 5,925 10,000ths. Now we want to go the other way. We want to start with a percent. No, I'm sorry. We're still on these. I'm sorry. So we are still trying to find the decimal notation. So we drop percent, move decimal to left. Here's one where they gave us a kind of a pie chart of different sports that people participated in percentages, and they asked us to turn all of these into decimals. So drop percent, move 2 places left, drop percent, 2 left, and so forth. So the methodology is the same. So what am I doing? I'm going from a percent to a decimal. How did I do that? Drop the percent, find wherever the decimal point is when it was a percent, and move it 2 places left. And so the answer to this was this one. So this is what, 1200ths, 600ths, 1500ths, and so forth. And now what are we doing? Oh, now we're going the other way. Now we're going to start with a decimal, and we want to go to a percent. How do we do that? Since you don't have a percent sign, you need a percent sign. So the way to think about that is to add percent and decimal to right. So you add the percent and you move the decimal 2 places to the right. So the answer to this one is, as you can see, 64%. And what do we do here? We add a percent and move this decimal 2 places to the right. We add a percent sign and move this 2 places to the right. So we get 72.2%, which is answer choice A for this one. Last one, add a percent sign, move the decimal 2 places to the right. So when I move it 2 places to the right, it's going to land here. And so this one is this answer here, 3.36%. So those were the problems that we had from the warm up activity this morning. So let's just do a quick review. What we primarily did on these problems was we converted percents to decimals, and then we converted decimals to percents. And so I said in the shortcut method for thinking about how to go from a percent to a decimal, you drop the percent sign and you move your decimal point 2 places to the left. Now, if you have a whole number as a percent, then you've got an implied decimal point here. And so what did we do? We dropped the percent sign and we moved this decimal 2 places to the left, and we got 70 hundredths, or that could be written as 7/10 as an equal amount. Notice the technique explained a little more fully. 70% is equal to 70 per 100, which is notational 70 times 1 over 100. These are the same because when you multiply 70 times 1 over 100, there's an understood 1 here, and you're going to get 70 over 100. But anyhow, so 100 can be written as 100, and this is the key. When you multiply 70 times 100, that accomplishes that movement of the decimal point. And so what are both of these doing? Both of these are replacing the percent sign. This is replacing the percent sign with that, and then this is replacing the percent sign with 100. So that's how we get away with just saying move the decimal point, drop percent, and move decimal 2 left. Now, the other problem we had was to start with a decimal and go to a percent. And you remember that the definition of a percent is some number per 100. And the shortcut technique is, well, you just add a percent to the value and then move whatever decimal point you have 2 places to the right. Now, let's a little better explanation of that. So what I said was, you move 2 places right, add a percent, and we would get 72.2%. Think about it in steps. So if I rewrite this as this value over 1, and then say to myself, I need to convert it to an equivalent amount per 100. How do I do that? Multiply the denominator by 100, multiply the numerator by 100. We've done that sort of work before when we had equivalent fraction work. And so that is now going to move this decimal point 2 places to the right, and the numerator is set at 72.2. The denominator is 100. And remember, the definition of a percent is some number per 100. So by definition, we've got it. Again, as you do more of these problems, you're just going to find yourself automatically when I need to go to a decimal. I'm going to drop my percent, move decimal 2 places left. I need to go from a decimal to a percent. I'm going to move decimal 2 places right, add a percent. But the calculational basis for those is pretty clear there on those 2 examples.